Welcome everyone to another Wednesday program. I'm extra excited about this one. It's about P-3 pilots and P-3 planes, Orions flying out of Moffett Field. And people who have been in Silicon Valley for years have seen the large four-engine planes flying out over the valley and heading out to the Pacific. But most people don't know what they're doing and what they're up to. And I happen to be fortunate to be the son of a P-2V pilot, which was the predecessor to the P-3 Orion. So as a kid, I just was fascinated by these planes. And I was always amazed that they were protecting America by patrolling the Pacific Ocean and finding a submarine or two. And you realize it's quite a needle in a haystack. And so it's just an amazing thing that they're doing. And they're flying day and night, covering from Alaska to South Pacific. And it's just a wonderful thing they did during the Cold War to keep us safe. So I'm just really excited to have Andy Pease here to talk to us. And so let's give him applause.
You guys can hear me okay? I've got kind of a hoarse voice, so let's get this thing. So I'm going to talk just a little bit about me and the plane, and then what a P-3 squadron is really all about, what kind of mission we did. I'm going to actually talk about an actual event that happened in my squadron. It was actually a ditch in the North Pacific, so you guys may actually remember that. And then I'll hopefully finish on a little humorous note. So first, my aviation career, I went to flight school after going to the Naval Academy and grad school. Everybody starts out in Pensacola. Back in those days, we flew the T-34B. This is actually a picture of the T-34C. The difference is that this is a turboprop, and what we flew was a recip engine. I wanted to fly propeller airplanes, so I went on to Corpus Christi, and so the cadence for all Navy pilots is you start out in primary, everybody's together, you're graded on everything you do, and depending on your class rank, then you can pick either jets, propellers, or helicopters. And propellers were my first choice because I didn't like going to sea, actually. I thought, when I fly planes, I want to land on terra firma. So in Corpus Christi, we flew the S-2. This plane now is totally phased out. It's interesting flying this because a lot of times we'd have real emergencies when we were flying with instructors because it was such an old airplane. Then after flight training, when I got my wings, again, everything's based on your class rank and your grading. So I wanted to go to first P3s was the plum job, and Moffett Field was the plum location, and I was lucky enough to get that. So I was deployed out of Moffett Field, and I did deployments in these places. And then I thought I'd be an airline pilot, and actually the airlines weren't hiring then. Great thing for me. So I actually got a second tour across the field in VP-31. VP-31 was in that hangar that's now all lattice structure that Google has taken over. And this is a replacement air group, so we would actually train people that were going into the squadron. So everybody that goes into a P-3 squadron has to first go through a RAG. And by the way, that's true for all Navy pilots. In any aircraft, there's always a RAG for that type airplane. So total, I had about 3,000 hours, most of it in the P-3, and I did a lot of instructor time. So let's talk about the P-3, but first its predecessor was based on the L-188. How many people knew that? The Lockheed Electra. And Lockheed Electra was actually a commercial airliner. It was bought by American and Eastern and a number of airlines, and actually it was unsuccessful. Initially they had these wing separations, 2 of them, and they had a lot of other problems. And they thought that the wing separation was because they didn't have a strong enough wing root or engine mount. So what Lockheed did is they actually put an initial fix, and they strengthened the wing roots and the engine mounts, but unfortunately that fix didn't really hold true, and so the plane was replaced because at the time Boeing was coming out with the first commercial jet, the 707, and that kind of doomed the Lockheed Electra in terms of a commercial career. But so Lockheed didn't give up on the airplane, thank goodness, and they found out that the reason that these wings were actually cracking was they figured out that when 2 propellers crossed the leading edge of the wing at the same time, that could actually develop a harmonic. And it was all very random, because at the time the propellers just spin and you could adjust them to a speed, but they weren't synchronized or synchrophased. So the actual fix for this was they put in a new system called the synchronization fix. And so now when they fly these planes, you pick a master either inboard, and then the master basically makes sure that all the other props don't cross the leading edge at the same time, and they're all synced to the same speed as the inboard prop. And that actually fixed the problem, and so now the P-3 was born, and it replaced the P-2. I think you said you had your father flew the P-2. There's a P-2 actually at Moffett Field, or at least there used to be. I don't know if it's still there anymore. And you can always tell these ASW planes because of this distinctive tail that's called the mad boom. And later on in the presentation, I'll tell you what the mad boom is all about and how it's used in terms of ASW. There were 757 P-3s built, and it's only one of only 5 aircraft that has served continuously in the military for 50 years. Can anybody name some of the other 4? Anybody, any guess? Hercules is one. B-52 is one. KC-135 and the U-2. Interestingly enough, 2 of them are from Boeing and 2 of them are from Lockheed, or 3 of them are for Lockheed, because obviously the P-3 is from Lockheed. It's used by 17 different countries today still. And right now the P-3 in the United States is being phased out by the P-8A Poseidon, which is really a 737, which when you think about it, it makes a lot of sense, because boy, you talk about a workhorse in commercial aviation, and there's maintenance is going to be much easier with a Poseidon. So that's the overview on the airplane. So now I'm going to kind of get into the Navy part of it. And so the P-3 Navy is divided up into the Atlantic Fleet, Compact Wings Land, and I'll talk more about Compact Wings PAC, because that's where I was stationed. And throughout this presentation, or the next couple of slides, you'll see things that are in bold blue, and all that indicates is what I did, or where I was stationed, or jobs that I actually had. So the home bases of Compact Wings PAC, the headquarters is actually at Moffett Field, and there's 7 operational squadrons. I was in VP9, as you can tell by this plane. And then Barber's Point, which is on the island of Oahu. Barber's Point is now shut down. It's actually in the southern part of the island. It's actually east of Honolulu. And there were 5 squadrons there. And then we had overseas deployment sites, and the deployment sites were in Misawa, Japan. That's about an hour flight north of Tokyo. Kadena Air Force Base on Okinawa. QB Point, which we used to call adult Disneyland, if anybody who hung around the Philippines. Well, I see a few grins, so you know what I'm talking about. And then Adak, Alaska was a detachment. And the main mission of the P-3 was obviously anti-submarine warfare. So if you look at the configuration of where all these bases are, it kind of covers the Pacific Ocean. And Adak was there because out of Petropavlovsk is where all of the Soviet nuclear submarines launched. And they'd have a pathway to a datum that was roughly about 1,000 miles off the coast of California. Not all planes that you saw flying overhead were going out to hunt submarines. Most of those were pilot trainers. So every plane that you saw circling around here, believe me, they were pilot trainers. Maybe 1 out of 500 could have been a plane on an actual mission. We also did things, and this is what the pilots actually love. We do this thing called Maritime Air Patrol, and we go along known shipping lanes at about 1,000 feet, and anytime we'd see a ship, we'd drop down to about 200 feet. If you guys ever flown a plane and go low over the ocean at 200 feet, boy, that's a real high. Pilots loved it. The back of the crew hated it. So, but we would identify shipping ships that were carrying various cargo. We'd identify the name of the ship, what it was carrying, the approximate weight, and we'd relay that on to Washington for intelligence. So that's kind of an overview of the Compact Wings PAC, or the wings, the the West Coast P-3 Navy, and more particularly, what does a squadron look like inside? So I'll tell you what VP9 looked like, but all the squadrons were the same, obviously, other than their name and their logo. So each squadron had about 350 personnel. 40% of them were air crew. That meant the rest of them were all maintenance and support staff, because the idea of the P-3 squadron was it could deploy lock, stock, and barrel to any place and be totally self-sufficient. Out of those 40% air crew, they are divided up into 12 crew, and each squadron had 9 of these. Usually one was a hangar queen to keep maintenance parts available for everybody else, but they'd always rotate around. And the organizational structure, so while you had a job, a flying job, in my case I was a pilot, but everybody as an air crew had a ground job in one of these 8 departments, and you can see the jobs that I had. And in some sense, that's a lot like a regular civilian company. You have administration and operations and training and maintenance, obviously tactics and safety, well, even safety maybe. Whoops. And the way it works, at least for the officers, is it would be a 3-year tour in a squadron, and the officers would actually rotate through each job for a year before they go on to the next job. In my case, I actually spent 4 years in the squadron, again, because my commanding officer liked me. I was actually put in my letter of resignation. He spent a lot of time talking me into staying in the Navy, and he offered me a department head job, so I was a safety officer in my last year there as a lieutenant, which was somewhat unusual. So now let's do a deep dive into the airplane and see what the air crew's like and where everybody fits. So the plane carries 3 pilots. All pilots are designated naval aviators, and that's a distinction by these wings with a single anchor. And they're pilot, co-pilot, and the third pilot sits in the back of the galley, usually on crew rest, because typically what you do is you'd rotate somebody out every 2 hours so you didn't get fatigued. This plane, and I'm sure that they don't have these guys anymore, but in the middle seat, so right here, was a flight engineer. And if you've ever been inside a cockpit of a P-3, if you look overhead, there's just a whole scat of dials and gauges. Same thing with the dashboard. And then off to this side is a circuit breaker that basically controls everything in the airplane. So the flight engineer was really a systems expert, and he would take care of most of those dials and knobs and circuit breakers for you. Now let's go to the guys in back, or we affectionately call them the Gibbs. So you can see a bulkhead here. And the crew that actually did the tactical problem was led by a guy called the TACO, or the tactical coordinator. Now he was called a naval flight officer. So naval flight officers have wings like this, but the difference being they have actually cross anchors instead of a single anchor. So their anchors cross like that if you're ever interested. So you see a guy like that. Most planes now, even jet planes, have a naval flight officer with the pilot that does a tactical problem. The days of single piloted airplanes are really over. The A-7 was the last plane that actually did this. The TACO actually runs a tactical problem, and I'll actually go into a typical tactical problem and how we went about doing that, but this is the guy that runs the show. The junior guy, the junior naval flight officer, is actually a navigator. So when somebody first arrives in the squadron, he starts out as a navigator, and they do all the navigation and communication and reporting. Believe it or not, in this plane, we actually had a sextant that would stick out of the overhead. So when we were out over the Pacific before GPS and before all the modern navigation techniques, occasionally you'd have a navigator that would do a star shot. Pretty scary when you think about that, if you've ever done a star shot before. And then after a couple years, the navigator, as he learned how to actually prosecute a mission, he'd fleet up to the left side of the airplane and become a TACO, much like pilots rotated through third pilot, co-pilot, and then patrol plane commander. The rest of these are mostly enlisted, all enlisted positions. So the key guys were these acoustic operators. We call them Sensor 1 and Sensor 2. They were always electronic warfare ratings up here. And they sat in the middle of the airplane. You can see 2 seats here. And what they did is they monitored the output of the sonobuoys that we used to carry on board. So if you look on the underside of the airplane, and this is characteristic of the C model, not the B model. The B model, by the way, all the sonobuoys had to be launched from inside the airplane. Where the C model, you would preload 84 sonobuoys based on the type of mission you're going to do. And then just as an insurance policy, you can see a rack right here. You carry an additional 80 sonobuoys, so if you needed to, you could launch them from the inside of the airplane. Yeah.
8 or 80?
80. 84 underneath, another 80 inside. So when you're out on a mission for 4 hours, you drop a lot of sonobuoys, believe me. And so the type of sonobuoys, and I'll actually get into these, how they're used differently, but you had the cheapest one, the low-far buoy, which was at the time about $300, and it basically would say you have contact or not. A dive-far buoy was also just a passive sonobuoy, so it could hear, and it also tell you if you had contact or not, but it also point which direction you're going. These were about 3 times more expensive than the nose, so you didn't just throw out a bunch of dive-far buoys until you had some idea of where he was. The real expensive buoys were these active sonobuoys, and they were, as you would think, they would actually ping the target, and you would only use those in attack criteria. Yeah. No, they sink. Actually, the buoys have a life setting, and when they're done, they scuttle themselves and they sink to the bottom of the ocean.
Cap dissolves. That's in water.
Right. That's right. We also carried what's called a non-acoustic operator. This guy actually sat right there, and he was responsible for monitoring the forward and aft radar and also the mad boom. We'd carry an in-flight technician, and this guy was probably the smartest guy in the airplane. He would basically be able to fix damn near anything on the airplane if it was possible to fix. And then at that time, we also used to carry an ordnanceman. The ordnanceman actually got phased out about 5 years after I left the Navy because they were, especially with the C model, since everything was kind of preloaded, once everything's loaded, there's very little for him to do, other than, of course, load weapons. But, you know, if you were going to load weapons on the airplane, all that was done during pre-flight, and usually the pilots would help out for that. By the way, the pre-flight of an airplane like this back in the day was 4 hours. Now, for the pilots like me, we file a flight plan, get our weather brief, look around the airplane. We're done in about a half hour. So after you're done doing crossword puzzles or whatever, you know, you're trying to find things to do. So there's a lot of help that can be done to get the plane ready. In terms of ordnance, there is a bomb bay. And in the bomb bay, we could carry torpedoes and special weapons. That's always a question that gets asked. Did you guys carry special weapons? And you're not supposed to say yes or no, but obviously we did. We could, not we did, we could. And then we'd have over-the-wing stations, which could also carry rockets and missiles, SIVA, and gravity bombs. And we used to practice doing that a little bit. Before every time we deploy, we'd have to go out and get qualified to do all that sort of thing. So now I'm going to go into the anti-submarine warfare basics. And this is going to be broken down into the search, the localization, the tracking, and the attack. So we'll go into 4 individual phases. So first, ASW basics. Sound is a primary physical phenomenon that's used to find submarines. And one of the first lines of defense, and this was put in after World War II, was the SOSUS system. Has anybody heard of SOSUS? I imagine a Lockheed guy. No? SOSUS, anybody? The captain has. So SOSUS was done after World War II, and what they did is they put in these hydrophone arrays, and they mounted them on continental slopes or seamounts. And these arrays are connected to various monitoring stations. And there's about, 9 monitoring stations, and 2 of them are California. So if you guys ever drove down to Big Sur on Highway 1, past Carmel, there's a kind of little peninsula that sticks out over the ocean, and you'd see a kind of what looks like a military facility. That's actually a SOSUS station. So that is actually the tail end of some wires that run on the ocean floor and are able to detect sound. And these hydrophones are highly optimized for long-range sound propagation, and they can detect very small power changes for pretty large distances. So once one of these SOSUS arrays actually establishes contact, that establishes what we would call a datum, or an area of probability for your target. And whenever that happened, then every one of those bases I pointed out to you, there's a ready alert squadron, and the ready alert squadron already has a ready alert crew. And when you're on the ready alert in a ready alert squadron, and you would have to spend the night in a bunk room above your plane or in the hangar, so that if you did get one of these hits, we could be off the ground in an hour. So the first thing you did as a ready alert crew is you kind of pre-flighted the airplane and you loaded it up. And then if you ever got one of these things, you just went almost immediately. So let's take a datum. Let's say that that actually happened, and the datum is here. It's about 1,000 miles off the coast. And so what would happen, like I said, the P-3 would launch rather quickly. It typically, out of Moffett anyway, it'd be about 1,000 to 1,500 miles. So it'd take us anywhere from 3 to 5 hours to get out there. And the crew is asleep when we're doing it. And then you're on station for 4 hours, and then it's obviously the same amount of commute backward. And so, long day, especially when you consider that the pre-flight's 4 hours, the flight itself is 12 hours, and the debrief is roughly 4 hours. Because they take the tapes, we tape everything, and they go through the whole flight with you on the ground. So these datum sizes are super large, so if you ever got a hit on a SOSUS array, the first thing they do is divide up the datum into searchable areas, because you can't go out and search 10,000 miles and 10,000 square miles at a whack, but certainly 500 square miles is very manageable. So what happens is the P-3 would arrive on station, and as he's approaching on station, they descend to 10,000 feet, and they always shut down the number one engine, because the number one engine doesn't have a generator or any other accessory equipment, and we call that loitering the engine. Loiter is a term for a routine shutdown of an engine to save gas. By the way, when you're out on station, if you get light enough, you could actually loiter 2 engines. The only restriction, if you had both outboard engines shut down, you couldn't go below 1,000 feet. But you could fly all day long on 3 engines, no problem, considering you were light enough. So here's the P-3 at 10,000 feet with an engine loitered, and the first thing he does is drop what's called a BT buoy, a bathothermograph buoy. And this bathothermograph buoy would actually deploy a hydrophone down, and it actually detect the sound propagation and how sound would propagate in the water. So it actually track temperature versus depth, and that would establish a thermal layer. And it turns out that sound echoes off these thermal layers. So if you had a thermal layer like I depicted here, you would have what we call a direct path. So you could hear a submarine roughly about 2,000 to 4,000 yards. That's 1 to 2 miles. And interestingly enough, sound would bounce off a thermal layer underneath and it would echo back up. So you'd have these things called convergence zones. And the convergence zones were a good 8 to 9 miles away from where the direct path was. Obviously, this makes finding a submarine a little more complex, because when you find it, and I'll show you the patterns there, it's not right where you put the sonobuoy. So now let's kind of go into the search and how does this work. I've talked to many different TACOs, because it's been a long time since I've done this, and different TACOs all had different geometric plans, patterns that they'd like deploying, their favorite type of search pattern. So a guy who was my TACO, basically, he liked the straight line approach, so he would deploy 16 buoys in a single line like this. And this depicts what the direct path range would be, and then the first convergence zone. Like I said, some of these, it depends on the conditions, but I've heard of people that actually herd a submarine out 4 convergence zones, which could really make solving this problem a real problem, you know, if you want to try and find out where the buoy submarine is. So this depicts how sonobuoy actually deploys. So when the sonobuoy deploys, and we actually start with LOFAR buoys, like I said before, there's actually an inflatable float that keeps the hydrophone dry and it keeps it above the water surface. If it gets wet, it's not really a problem with a radio transmission. And then there is a hydrophone and stabilization equipment that deploys. The depth that it deploys and the time it's in the water is actually all selectable by that TACO. So you can actually, they can talk to these sonobuoys and get the right depth that they want. And by the way, it's not any depth, it's in either or. Like it'd be either 100 feet or 300 feet. But you want something that gets below the thermal layer so you have a better shot of hearing a submarine. And then the acoustic information is relayed via UHF or VHF frequencies. So somebody asked me about these antennas, the UHF antennas here, the VHF blade antennas up there. So that's how you could actually talk to the, or communicate with the sonobuoy. And again, those two sensor operators that were in the middle of the airplane, being sideways, they would actually monitor this. So they dial in the buoy frequencies, and they'd also dial in frequencies which were characteristic of the target you were looking for. So in our case, we were looking for obviously Soviet submarines. And back in the day, the most two common frequencies were 147 hertz, which really is how their main cooling pump operated, or sometimes if they just had a coffee maker or any sort of a electrical appliance, and that would show up on the 50 hertz line. Back in the day when we were doing this, the Soviet submarines were really noisy as hell compared to our submarines. As a matter of fact, when we used to practice on our FBNs, both the fast attack and the FBNs, we would have to tell them to turn on more equipment because we couldn't hear them. So the range in which we could see our submarines was only 300 to 400 feet, where with the Soviet submarines it was 10 times that much. So getting back to our problem, we lay in this pattern, and the sensor operators are watching these preset frequencies, and hopefully they get a contact, like I depicted here. Now, if you get a contact, you don't know if it's a direct path, the first convergence zone, the second convergence zone, or so on. So once you do that, you actually drop now a DIFAR buoy on top of that contact, and hopefully it'll point in a direction, and that'll give you an idea of how to continue the search. And again, you're using DIFAR buoys, which are passive, so the submarine has no idea that they're there. They can't hear them enter the water, and there's no sound that is emitted from those buoys. And once you have contact, then the P-3 drops a little bit lower, 5,000 feet, because now you're kind of getting into the area. You don't need to be as high to monitor a big rain pattern. And then you'll drop a second DIFAR buoy on the top of the contact, and I'm obviously totally simplifying this problem, but you get the idea. It's really a geometric problem which you're dropping a bunch of buoys in pattern and you're trying to get triangulation to get a location as to where the submarine is. So let's say we found them and now we're tracking them. And by the way, we'd find a lot of Soviet submarines, and so everything I've told you up till now, we used to do this all the time. And once we found them, we would track them, just like I'm about to show you. So the idea of tracking them, again, you descend a little lower to make sure that you're in good contact with the sonobuoys, and you'd always try and drop these buoys ahead of the target. And so you'd want the submarine to pass through your target. Again, the submarine doesn't know you're there, so he's not really going to alter his course unless he was going to do that anyway. Always try and have 3 sonobuoys in contact, and the idea is to try and determine what the submarine's course and speed is. And like I said several times, the P-3 is in a complete passive mode. Now, this is something we would practice on our own boats, not with real weapons, but this is how the problem actually terminates is when you go into the attack range, now the P-3 descends to 2,200 feet. So if you had 2 engine loitered, you'd restart one of them first, and then you'd switch to an active buoy. And obviously the active buoy will bring it to submarine, and now the gig is up and he knows that he's being actually followed by a submarine, because obviously they can hear that. And that's where this mad boom comes into play. Now, this mad boom is really a fascinating piece of equipment. It actually detects deviations in the Earth's magnetic field caused by large objects. Could be a whale, obviously a submarine would do that. And so that sensor operator, the non-acoustic sensor operator that's on the starboard side of the airplane, he will be monitoring that. And so the attack criteria is if you have 3 consecutive fixes within 300 yards, or you get a MAD detection, that's considered to be attack criteria. And you can launch your weapon and boom, down he goes. Any questions on any of this? Because now I'm going to segue into another area of the talk. Yes?
Has there ever been anything like that happen?
No, no. Not in the P-3, probably in World War II with, well actually P-2s weren't in World War II. They used to use, yeah. So, no. But it was a huge cat and mouse game. And again, like I said, when we were based out of Adak, you'd try and catch them just as they were coming out of the throat of Petropavlov out of port and track them. Yes?
What is MAD?
MAD stands for Magnetic Anomaly Detection. This tells...
They don't actually see the magnetism from the submarine.
No, so this is passive as well, because actually the Earth has these magnetic fields that are actually patterned on the plane. So if you actually saw, and it's interesting because if it went through let's say a magnetic field that's a vertical and it passed through horizontal, that caused the biggest deviation in the field. But if you had a submarine that was running parallel along with that, it'd be a little less so. But we had operators that were trained to see the difference and to help us detect which way he's going. Okay? Now, the next phase of my talk, yeah.
So it is interesting that you basically had to track submarines because they all had, a lot of them had nuclear missiles pointed at
Yes.
the U.S.,
Right.
right? But what would the plan be? Would you wait for first missile to go off and then kill all the
So we would have to be ordered to attack. So we'd have to have the green light. You could not make that decision on your own. So when I was flying, yeah, you'd be at war. But obviously when I was flying, it was all the Cold War. So there was a huge cat and mouse game between us and the Soviets in many regards. Yeah.
What would happen now, once you put the third sonar buoy out there and they knew now they're being followed, would the sub go into some kind of...
Absolutely. So you would wait until last minute. You'd have a real good idea of where you were. You'd have a good idea of where he was, and your airplane is already positioned to be able to attack him. Mind you, you don't have to drop this thing right on top of them because the torpedoes were homing torpedoes. And all you had to do is they'd be able to find the cavitation noise of the submarine, and they'd go right up their butt.
Did the Soviets have similar cracking capability of ours?
No, they didn't, because our submarine, well, I'm sure they did, and the Soviets did have a version of the P-3. It didn't have a MAD thing on the Stinger, but it's called a Bear airplane, and it was actually, didn't go down as low as we could go. One of the curious things that I found about now the Navy's transition to the 737 is there's a real reason why the Navy stuck so long with the propeller airplane. Well, you guys are all airplane drivers, and so you know that the propeller develops instant thrust, where commercial airplanes like the 707, any commercial airplane, there's a turbofan. Basically, there's a spooling process that takes hold. When you put power on a P-3, the result, the instantaneous of putting more power in the airplane and going faster. As a matter of fact, I took a plane down to Edwards Air Force Base to the test pilot school down there, because they like flying different airplanes. And I can remember these guys, by the way, had just finished flying the SR-71. As a matter of fact, when my crew went down there, they said, "Do you want to hear the debrief on the last plane we flew?" And when I found out it was the SR-71, I said, "Absolutely." I'm fascinated by the plane. They were talking about how fast it was and this and that. And so now the next plane up was a P-3, my plane. And it's going, oh, fuck. Yeah. prop airplane. My God, this is going to be boring. So I remember we took them out in the flight the first day. So I made sure the plane was very light, no gas on the plane, except for as much as we needed for the flight. We had a minimum crew, and I remember putting the guy in the left seat, and I said, so we're going to do a high-performance takeoff. And the guy kind of snickered like, yeah, sounds like an oxymoron. I said, so trust me, if you don't do this right, you can actually stand the plane on its tail. So, you know, you apply max power when the plane's light, this thing can actually do a wheelie, and you could take off inside of 1,000 feet. So you could see this guy's eyes get really big when he started doing it. So I stopped catching shit about being a prop pilot after got a chance to see what that was about.
You had that diagram on the plane about the fuel, you just mentioned the fuel.
Yeah.
Using the fuel for takeoff. The entire wing, is that a fuel cell?
It absolutely is. There's fuel in the wings, and that's true for all airplanes. Anybody know the reason for that? Center of gravity and weight. The weight's where you're generating lift, so it's almost like free weight. We also carried a fuselage tank as well. So yeah, there is a fuel control system in there, so you would actually feed from different tanks. But definitely the wings are wet, and then there's a fuselage tank as well.
The tanks go all the way to the tips?
No. Oh, the tanks are the wings? Yes. Pretty much, yeah. If you put a bullet hole in the wing, it'd probably leak. I mean, if you just punched a hole in the wing, because that's true with most airplanes, that they don't have bladders.
How many gallons approximately?
And all the times I forget how many gallons. I want to say, I'm going to say 42,000 gallons, but I don't remember. Enough to fly 14 hours. I mean, the longest flight I've ever been on in a P-3 has been 14 hours and 20 minutes. It does not have in-flight refueling capability, so whatever you carry is as long as your mission can go. Okay? So, how many people remember a P-3 back in 1978 that went out over the Pacific Ocean and had to ditch and got picked up by the Russians? Anybody remember that incident? It was a plane that was based out of here but detached in Adak, Alaska. No one remembers that, huh? Okay, well that was flight Alpha Foxtrot 586. That was my squadron. And from June through December in 1978, our squadron was deployed in Adak, Alaska. And Adak is obviously a very strategic base, or at least it used to be, because of the vicinity to Petropavlov, where all the Soviets came out of. So on the 26th of October, one of our crews, actually the plane commander was my boss, who was the safety officer. He was the pilot in command. And they were on a 9-hour secret mission in Rough Cut Delta. These missions were called PARPROs, and what we used to do, and I think we can talk about this now because they don't do this anymore, we used to fly in an area, and then what we do is we make a beeline for the coast to see what, and then we'd have an AWAC plane above us to see what kind of air defense systems they'd have. So you'd always fly right up to 50 miles, and then you'd turn around and just screw with them, if you will.
And they did with us.
As they did with us, that's right. So at 8:45 in the morning, 0845, the plane took off. There are 15 souls on board. There's one guy here that used to be with Lockheed and flew in an observer seat. So we used to take observers from the wing. These were actually not civilians, so they were military, but we had 3 observers for the wing on this flight. And they flew out on station, and it was pretty uneventful. It took them about a couple hours to go on station. And when they got on station, as you always do, you shut down the #1 engine to conserve fuel. And also what happened is that Sensor 3 operator, using our forward and aft radar, started scanning the area to see if there are any commercial traffic in the area. And he actually found a Soviet trawler that later was identified as Missivian. And he also spotted a Liberian tanker that was headed west for the coast. And so they operated like this for roughly about an hour and a half, between 3,000 and 8,000 feet. And roughly about 2 hours after they shut down the engine, the weather started deteriorating. By the way, if you do shut an engine down, you can't fly through clouds, because then you can ice up the engine, and you don't want to ice up a static engine because you may not be able to restart it. So they descended below the cloud layer to 7,500 feet, and they basically restarted the engine, and so far everything was okay. Until, as luck would have it, the third pilot, or the most junior pilot, was sitting in the left seat. The second most junior pilot was sitting in the right seat. And remember, we carried 2 flight engineers. The most junior flight engineer was sitting in the middle seat. So the 2 most experienced guys were not in either of the operating seats. So the third pilot, by the way, this guy who did this ended up on my crew after this event. He actually just sort of adjusted the power levers. And as soon as he touched the power lever for the number 1 engine, the engine went off speed. So as I'll show you later on, there is a little RPM indicator, and it will basically show you the rotation of the propeller, and it's always normal is 100% or 0 if you have the engine shut down. 100% is a normal operations. If it's over 100%, that's considered an overspeed, and the prop is spinning faster than it should. By the way, when that happens, it's a really high audible off-speed tone, so it's really pretty scary when that happens. And the RPM kept climbing. So the procedure in the manual, or NATOP's manual, is you shut down the engine. And so when you shut down the engine, and here's a blow up of the cockpit, so this is the number 1 engine indicators here. So there is an emergency shutdown handle that's color-coded yellow and black, and you just pull that thing out. And then you have all the key indicators for that engine: shaft horsepower, the turbine inlet temperature, the fuel flow, and the RPM. So when you pull the E handle, it's supposed to shut off all air, oil, and fuel to the engine, and basically drive the propeller to a full increased position, so it's actually perpendicular to the slipstream, so basically it basically doesn't create any drag. So when you do shut the engine down, it's supposed to drive the prop to this full increased pitch position, which is 90 degrees, and this is what you'd expect. You'd expect the shaft horsepower to go to 0. The turbine inlet temperature will wind down as the turbine kind of cools off. That won't be immediate. The fuel flow will go to 0, and the prop and the RPM goes to 0. What they actually had was all the first 3 things happen normally, but instead the RPM went to 131%. Really loud, really noisy, caused a lot of vibration in the plane, and the blade went totally flat. So it's also causing a lot of drag. Still not a huge problem yet. And so, but they did have to abort the mission, and they started heading for the nearest base, which was a place called Shimia, one of the last islands on the Aleutian chain. There's actually a Coast Guard station there where they flew KC-135s and so on and so forth. So they aborted the mission, and then about 10 minutes later, they started seeing this film come out from the prop dome. So you could see it kind of filtering off right between where the dome is, and it attaches to the engine nacelle. And so during this time, they started sending encrypted aborted messages. They said that you better launch a ready alert crew, but we're not in danger now. Just get the ready alert crew to get ready. And then about a half hour later, they got their first fire warning light. And they, in these planes, each engine has what's called an HRD bottle, or a high rate discharge bottle. You can port either HRD to either engine on the same wing. So in other words, you got 2 shots. Even though you got 4 bottles, each bottle can only work across the wing. As soon as they got the fire warning light, there was a big oh shit in the cockpit. Why? Because all oil was shut off from the engine. So in other words, you had a gearbox that was turning at about 135% and with no oil or no lubrication. And so now they knew that maybe this was a bigger problem than they thought. So they actually pushed the HRD bottle, and it did extinguish the fire. Now they requested a search and recovery plane because now they're not sure if they can make it back or not, but just as a precaution. And then they thought of, and by the way, this is 48 minutes after they restarted the airplane, they said maybe we ought to restore oil to that plane. And how you do that is you push back in the E-handle, flight engineer reaches back and pulls out the oil tank shutoff valve circuit breaker. So now that's open. So when he pulls the E-handle again, now there's oil going back to the gearbox. But now you've got a gearbox that's probably pretty trashed by now. Imagine you run, hot and trash. So as soon as they did that, they saw white smoke coming out, leaking fluid, and soon, sure enough, a few minutes later, they got a second fire warning light. So they used the remaining bottle to put that fire out. But they could see sparks and flames visible within the engine itself. So now they knew they were in pretty deep doo-doo. They issued a Mayday statement. They said that they were probably going to have to ditch because they're still about 290 miles. So that's roughly at the speed that they could. By the way, you can't go at normal air speeds with that much drag. So about as much airspeed as they can muster out of this plane was about 130 knots. So you're looking at least 2 hours of flying time. And they said that's probably not going to happen. So now the plane commander told, this is all stuff that they're doing in the back of the plane. They started getting rid of all their crypto gear, getting rid of all their pubs, destroying all their gear, and keeping in constant touch with Elmendorf, who is the site that was monitoring these guys. And then they also noticed they put on their anti-exposure suits. Meanwhile, a Coast Guard C-130 was diverted. He was about 1,300 miles away, still quite a ways away. And now they had their third fire warning light. Kind of fucked, right? I mean, there's nothing you could do. You couldn't blow it out. And at this time, the plane commander was telling the Sensor 3 operator, the non-acoustic operator, fire up your radars and see if you can find those ships. Remember that Liberian tanker and the Soviet trawler? So he did see the Soviet trawler 16 miles west of the airplane. Good enough, right? So they start heading for that. And now they're telling Elmendorf they probably got about 2 minutes to ditch. And the Soviet trawler's 20 miles away. But now they start focusing a lot on the sea waves, or, the sea state conditions. So now, a few minutes later, the fourth fire warning light came on. And they tell basically everybody's preparing to ditch. They actually have a transcript of the TACO, and this guy was as cool as a cucumber the whole way. He was talking to Elmendorf continuously. We're at 500 feet, we're 90 feet, just all the way down until ditch.
Same engine, fourth fire and same engine.
Fourth fire, same engine, yeah. These are the ditching conditions. So I kind of heard you guys talking out there that you don't like flying in wind. 1,500, so mind you, this is the end of October in the North Pacific. You're not too far from Alaska, and it was 1 to 3 miles of visibility. The wave height was up to 20 feet. The wind was going out of the southwest at 43 knots. And so these guys were doing 120 knots or 77 knots ground speed, and they were actually bringing it in. What saved everybody on this airplane was the fact that my boss was actually an ex-seaplane pilot. Because I bet anybody that had never landed a plane on the water would have never been able to do what he did with those conditions. So he actually ditched the plane, and when the plane hit, it actually skipped 3 times before it actually stopped. And the damage was that the starboard wing came off, the mad boom came off. The big thing was that the hydraulic service center door broke loose, which meant that the water came right into the airplane immediately. And the galley bench, I think somebody talked about a galley bench. Well, a couple of people were ditching in the galley bench, namely the off-duty engineer and one of our observers. And it broke, and it actually, we think that's what killed our second flight engineer. So when the plane actually ditched, this is where everybody was. Everybody in red is the actual crew. The people in blue are the 3 observers that came in from the wing. And these are the places that you can get out of a P-3. So each wing has an over-the-wing exit, just like all airplanes. And there's also a hatch over the flight station, which the flight crew is expected to get out of. So obviously everybody has, on your ditching placard in the airplane, tells you which way to exit the plane and what your duties are, because they're also, the #1 life raft is on the left side. It's a 7-man raft, and there are 2 life rafts on the starboard side, a 7-man and a 12-man raft. So everybody's got their responsibility, and they went out according to the way they should. But the problem was on the port side, that 7-man raft on the port side they couldn't uncouple it. Apparently the hinges were rusted. So let me do a go-sub here first, and that is, up until this time, a P-3 never ditched in the open ocean. Even a P-2, there was never a recorded incident of ditching a P-3 in the open ocean. So, life rafts, yeah, we got to check them, but it's okay. Those anti-exposure suits those guys put on? They were full of rips and tears because they had never been inspected, because, you never need them, really. We even carry parachutes. There's never been a recorded case of anybody jumping out of a P-3 because they had to. So, it really kind of changed the way you think things. So this is where the people went. You see that the 3 guys, because they couldn't get out the raft on the left side, you can see too many people went out on the right side, or the starboard side of the airplane. And the pilot in command actually stayed on top of the airplane. So the second flight engineer never exited the airplane. Some people thought that the pilot in command was trying to count bodies, but other people said no, he wasn't. But in any case, the plane sunk in what people estimate to be 90 seconds. But they were able to deploy a 12-man raft. Notice that the 12-man raft is covered, huge raft. Only 4 people made it into that raft. And those are all the people that went out on the starboard side plus 1, because this raft, mind you, 40-knot winds with a big canopy overhead. This thing was like a sailboat, so it was going pretty fast. Meanwhile, 9 people ended up in the 7-man raft. And they were all watching the PPC. They were standing on top of the airplane, observing the things. And so once that was done, then he started swimming. And because of the wind was blowing this way and he was swimming that way, there was a separation. So 2 guys actually jumped out of the plane, out of the raft, the second pilot and the second sensor operator, and they tried to drag the raft towards the pilot. So for about a couple minutes, you could see them trying to close the gap, and it wasn't happening. So finally, the pilot raised his hands and just said, go. And so he was lost at sea. They did search for him for a couple of days, but, no luck there. So now we get into the search mode. So now you had these 2 rafts. By the way, they had flares and things like that, and their exposure suits, which didn't do them a lot of good. This raft here, the 7-man raft, was taking on a lot of water, so there's a lot of element exposure there. Meanwhile, the guys in the 12-man raft were fine because, lots of room and covered. So the first plane on scene was actually a C-135 out of Shimia, that island just north of there. And they arrived at scene, and they actually spotted the flares, so they did a circle pattern around the rafts. Meanwhile, the P-3 out of our home base in Alaska, the Ready Alert plane, had launched, and as soon as he launched, then he took over to search, and now they're waiting for that. Remember that C-130 that got diverted that was 1,300 miles away? They're waiting for him to come out, so when he relieved that, then the P-3 could go search for that ship to get those guys saved. So He actually found the contact. This was, again, the Russian trawler, and he was about 30 miles from the rafts, and he used his landing lights in Morse code, which he used the CEF, which is Morse code for follow me, and they responded, and they actually followed the plane, and they picked up at 2200 hours. They got in contact, and they said that it would take them a couple hours to get to the rafts, or at least the position that was relayed onto them. As that was happening, that second sensor operator that dove into the water to try and help the pilot, he actually succumbed to the elements, and he passed away in the plane. About 0145, the Sivian picked up the 4 survivors, and they got to the number 3 raft. That's the covered raft that had 4 people in it. And meanwhile, 2 more people died of exposure. Interestingly enough, if you look at the all of the crew members, the 3 people that died were all the sensor operators, and the oldest one of them was 20 years old. They were by far the youngest people on the airplane. I'm not sure what that, maybe they just didn't have enough body fat like us old farts do. I'm not sure, but anyway. And all of them were obviously in the 7-man raft. So finally the Sivian picked up the other 6 survivors and the 3 dead from the 12-man raft, and they were very, very weak. And so then they proceeded to Russia. Another thing I didn't fail to mention was that when we actually contacted that Sivian, they had to send a message to Carter. Jimmy Carter was the president at the time, and he had to send something to Brezhnev saying, would you please help us out, because obviously we weren't the best of buddies at the time, you know, us in the Soviet Union. So they continued to search for the pilot in command for 3 days, but obviously no avail. Meanwhile, the Sivian took about 24 hours, and they took all 10 survivors and the 3 dead to the Naval Hospital in Petropavlovsk. They spent a couple of days there, and then they flew a commercial flight to the interior where they had a bigger hospital in mainland Russia. They spent a couple more days there, and then they were all flown to Yokota Air Force Base in Nagita in Japan, and stayed there for a couple days, and then they were flown home to Moffett Field. The aftermath of this, I'm very familiar with this because it turns out I was the accident investigation chairman. My job in the squadron was I was the aviation safety officer, so I was responsible for investigating any accidents. Of course, when I got the job and I went to phasing school, I thought this is never going to happen to me because the accident rates were so dramatically low in the P-3. I had people from Hamilton, Allison, and Lockheed on the team, and what we found was the problem, the reason the prop wouldn't feather was the Naval Air Research Facility in Alameda started changing the O-ring in the dome of the prop. And they started using a more substantive O-ring, and apparently this O-ring was not as good as the previous ones. In other words, it would absorb oil and it would engorge itself. So it would actually nibble away at the thing. And the problem was that that O-ring was what separated the hydraulic fluid from the increased pitch side and the decreased pitch side. So if there's no hydraulic fluid keeping the prop at a more increased pitch side, the most increased pitch side is obviously 90 degrees, so you need hydraulic fluid driving that. And if the O-ring is leaking, then you're screwed. Because then, you know, it will be physics that will take the prop totally flat. They did do a JAG investigation, and a JAG investigation said that the ditch was, so that was the reason the plane had the emergency to begin with. The reason they ditched is, what they should have done is as soon as the prop didn't feather, they should have put it in the E-handle, pulled out the circuit breaker and pulled the E-handle out, and then they just would have had an overspeed prop that would have been lubricated, and they probably could have flown back to Alaska. Back in those days, so we have a NATOPS manual, which is the operating manual on the airplane, and there was a paragraph about this is what you should do possibly if you have an overspeed prop, but it wasn't part of the emergency procedure. So one of the things that we did with the Accident Investigative Board is we made that a hard procedure with the emergency shutdown checklist. So before, it used to be the emergency shutdown checklist is pull the E-handle, pull the HRD if you got a fire, and then be done with it. And now it's like, pull the fire, if it fails to feather, then immediately pull the circuit breaker, blah, 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 so on and so forth. So unfortunately, it was pilot error that was determined to cause the plane, and our squadron took a pretty big black eye for this. So,
You would say it wasn't pilot error, it was a procedure, right?
that's right, that's true. It's a gray area, that's right. But you know, the military wants to have a scapegoat, and they will basically,
Pilot that needs to escape.
and especially since he's dead, not there to defend himself. This is the first and only successful ditch of a P-3 in history. So rather than end on a downer, hate ending on a downer, one of the things that I did, I used to get a subscription to Aviation Monthly, and they had this letters to the editor in the back of the magazine. And there was this article written by a 5th grader, and I thought I'd share it with you because it's actually kind of fun. So this 5th grader writes, I want to be a pilot when I grow up because it's fun and easy to do. Pilots don't need much school because they just have to learn numbers so that they can read instruments. I guess they should read maps so they can find their way if they are lost. Pilots should be brave so they won't be scared if it's foggy and they can't see when a wing or motor falls off. They should stay calm so they will know what to do. Pilots should have good eyes so they can see through clouds, and they can't be afraid of lightning and thunder because they are closer to them than we are. The salary pilots make is another thing I like. They make more money than they can spend. This is because most people think flying is dangerous, except pilots don't because they know how easy it is. There isn't much I don't like, except girls like pilots and all the stewardesses are trying to marry them, so they always have to chase them away so they don't bother them. I hope I don't get airsick, because if I do, I couldn't be a pilot and I'd have to go to work. Thank you. That's it.